Can you solve this seemingly easy geometry problem? It's a variation on Langley's Adventitious Angles. Let's first label the vertices. A quick inspection of the problem, and we see that we have equal base angles, an isosceles triangle. So AC equals CB. We'll come back to that. Let's have a look at a few other angles. The apex angle will of course be 180 minus 80 minus 80, 20 degrees. The angle at AEB will equal 30 degrees, angle sum of a triangle. Across the other side, the angle ADB equals 40 degrees, angle sum of a triangle. Now from D, we're going to draw a line parallel to AB, and we're going to name the new point F. And then angle DFC will be 80 degrees because we have parallel lines and a transversal, which is CB. Draw another line, join A to F. And where it crosses DB, we'll name the new point G. Now we can form a quadrilateral. Consider the quadrilateral ADFB. Since AB is parallel to DF, it has one pair of parallel sides. Therefore, ADFB is a trapezium. Further, since triangle ACB is isosceles, any line drawn parallel to the base cuts the two equal sides at corresponding points. So AD equals FB. Therefore, ADFB is an isosceles trapezium. Now, an isosceles trapezium has certain properties. The base angles are equal, the top angles are equal, and the diagonals are equal. Further, the diagonals intersect at a point that divides both of them in the same ratio. So DG equals GF, and AG equals GB. Now we're going to identify a few other angles. EAF equals 10 degrees, and that AFB is 40 degrees because it's the mirror image of angle ADB. And because of angles on a straight line, then angle DFA will equal 60. And again, its mirror angle, BDF, will also be 60. And then due to the angle sum of a triangle, angle DGF will also be 60. So triangle DGF is equilateral with equal sides. Now we're going to come back to that because I want to draw another line. I want to join G to C, which of course falls on the perpendicular bisector of triangle ACB. So this bisects the angle ACB into two smaller angles of 10 degrees each. Now I want to look at two triangles that have been formed. The first one is CAE in red. It has base angles of 10 degrees and 20 degrees. Now look at triangle ACG in yellow, it has base angles of 10 degrees and 20 degrees. You see the way this works? Now, I'm going to equate the two triangles. We note that AC equals CA because that's a common line in both triangles. Angle ACG is congruent to angle CAE, both being 10 degrees. And angle GAC is congruent to angle ECA because they are both 20 degrees. We have two pairs of corresponding angles which are equal, and a corresponding side between those angles which is equal. Those two triangles are congruent by ASA, angle, side, angle. Now I want to look at triangle AFC, and we see that it has equal base angles of 20 degrees. It's isosceles. AF equals FC. Now we'll go back to our congruent triangles, and we know that AG equals EC because they are corresponding sides of our two congruent triangles. But we've also just discovered that AF equals FC. So AG and F are collinear. AF minus AG will equal GF. FE and C are collinear. F C minus EC equals FE. Remember that AF equals FC, so AF minus AG equals FC minus EC. Equals subtracted from equals, and therefore GF equals FE. Now, recall our equilateral triangle, and if GF equals FE, then we have another side equal to the sides of the equilateral triangle, and that triangle DFE is isosceles. We know that the apex angle in triangle DFE is 80 degrees, so its base angles will then be equal and total 100 degrees. So let's look closely at the base angles. 2 times x plus 30 equals 100 degrees. Just expanding the brackets, 2x plus 60 equals 100. 2x equals 100 minus 60. 2x equals 40. And finally, x equals 20 degrees. And there's our answer. Now, I encourage you to do this yourself, and I have a worksheet, which is free to download from my website, where you can do just that. The link is in the description below. As I said earlier, this is a variation on Langley's Adventitious Angles, published in 1922. The original problem is the one at top left. So this one you could call number 2. Now, I intend to cover all these problems in different videos. And you'll find those on my website or on my YouTube channel. I welcome your take on the problem in the comments below. Thanks for watching.